Yeah, we all know that Project Zero has launched that time, and there is AXCC and C Helen last year. He used O3 to find the bug in this kernel. And nowadays, large language models has become a major forces in the vulnerability discoveries. So later on, the Project Zero, they upgraded the nap time to big sleep, and with a lot of investment. And their findings yet are astonishing. They find a lot of high-impact bugs, that including the bugs in V8, Redis, and other well-known projects. So we found some limitations of the single-agent architectures, like the hallucinations and the limited context window. And there is some multi-step reasoning that may cause some false positive, and these bugs that need some crossfire tendencies. So as Richard Sutton has demonstrated that the decentralized goal-driven agents that can cooperate together with different rewards, so they can behave like an army. So last year we come with the idea that we make models behave together to like a peace crew. So here comes the Argusee. This is a multi-agent crew that every agent that works together, maybe with different prompts, maybe with different models. They have many tools like code browsers to find the code in your repositories since a given entry point. And first, we'll tell them that you are an expert, and every action is a tiny chain from the source to the code and their final observations. And we will tell him what to do and what not to do, and we will reward him $1 million if he finds a bug. And here is a tiny examples to start from the user prompt. So we will supply with a background and a clear entry point and some context, like some which parameters are from the user are fully under user control. And then comes the manager agent. The manager agent is the human interface. It accepts the entry point, it analyzes the functions, it identifies the key points, and then it decomposes tasks and it dispatches them to the auditors. And every auditors, they are just like workers like the soldiers. They will analyze these functions deeply, such as the memory handlings, the pointer logic, or the system machines. And finally, like these examples, one auditor says he finds a buffer overflow, and another says this is safe on the review. And to reduce the false positive, the manager will ask the checker to skeptically re-audit all the reasoning chains and to check the exploitabilities. So finally, the manager will give a detailed report, and this is the whole workflows. And we conducted many evaluations and real-world practice on the Argusee. First, we conducted the evaluation on the CyberSec Evo 4 dataset, and reached 100% accuracy because it's really simple. So next, we test Argusee on GPAC, which is a multimedia library with a long fuzzy history, and we found 8 vulnerabilities in 2 days. And that's simple. We just fed it with some interesting functions and some context, like which parameters are fully controlled. And here is one integer overflows. This is very simple, and the size is just 32 bits, and it will multiply by 2, and it will overflow to small values. So the next operation will cause some out-of-bounds access. And we think we might go deeper, so we choose the Linux kernel USB MIDI stack for the next target. And it is used to identify the MIDI device, like the piano, keyboard. And the MIDI 2 support has just landed, so we think we might just find some bugs. So it is the same. We also fed it with some interesting functions and some context, like we have the high-level understanding of the module, and we let it to ignore some low-level implementation of the USB stack, so it can focus on the MIDI stack. And surprisingly, Upon several steps, the Argusee success find a bug in its kernel, which resides in the converter to convert the MIDI1 packet to MIDI2 packet. And the buffer is just 4 bytes, but it will be accumulated up to 6 bytes, so there will be an overflow. And then there will be some overflow, out-of-bound access, and here is our demo. We just corrupted some memory objects and corrupted some TTEs and achieved physical memory, out-of-bound arbitrary read and write and gain root. So what's more, we think can we just integrate our tools with IDA? So we just use the IDA Pro MCPs and to fetch some decompiled pseudocode and cross reference. So you remember the latest WhatsApp zero-click change affected some Samsung devices? Our tool successfully found 10 days in these libraries. And why didn't Fuzzy find these bugs? I mean, my opinion is the Fuzzy is the struggle to construct some unreasonable and complex testing input. And it's really hard to rewrite some dedicated and complex hardness for each component. So at last, will AI replace our security researchers? My opinion is not yet, but it can be used to assist to understand the code. And maybe not one day the AI is strong enough to find every bug, and we are free from code auditing, and what kind of situation will we be? And let's see. Thank you, everyone. That's my report.